just a couple of ground rules for this. We're trying to record this thing so we can get it captured for video later. So we'll be running around with microphones. If people want to just state your name first and then ask your question, and we'll go from there.
Great, thanks, Marty. So I was asked to lead the panel discussion, and I have no idea what I'm doing. So this is good. I imagine this would be a bit more free-form discussion. I mean, we've all seen these before. So I'm just going to make it up as I go, and we'll see how that goes. But I did want to introduce everybody that's up here. We have, oh man, I meant to do a better job. Tony Zielinski from NVIDIA, Timur Christoph from Valve, Karen Gavam. Karen Gavam, yes, sorry, from LunarG, Bill Hollins from the Brenwell Workshop, Jean-Noé Morissette from Epic, and Ralph Potter from Samsung. And I'm Chris Glover from Google. We had some seed questions, or do we have?
We didn't get a lot of seed questions, so if you got some, feel free.
So do we have any? Do we want to start directly with questions from the audience?
That sounds reasonable. Unless you got a few that you want to ask.
I don't have any.
Yeah, all right. Let's get them from the audience then. Cool.
Let's see if anybody has any questions to begin with. Nobody? Peter.
So I guess just reflecting on Chris's session from this morning, there was this general idea of Vulkan being a general accelerator API and a HAL. I guess what's the panel's opinion on that one?
So I'll go last. Did everybody hear that? Do I need to repeat it, or yeah, great. So why don't we start? I'll go last. Why don't we start with Tony? What do you think?
I think it's a great API for general purpose use of anything compute or anything you would like to accelerate to the device. It does provide a lot of infrastructure which you don't have to develop otherwise. And Vulkan Video is an example for this. We're going to have a presentation tomorrow to talk about what does it take really to add Vulkan video to Vulkan, if you will. How much of the infrastructure we reused already. And we just have to rediscover the wheel, if you will. So we're also considering other things for Vulkan, like camera, for example, and other uses that definitely could fit very well in the framework.
Great, thank you, Tony.
Well, we saw earlier in a presentation today that it actually competes with CUDA and everything. So I think the short answer to your question is yes, it's exactly that.
Cross-platform is awesome. Explicitness is awesome. It puts control into the hands of the application developers who really know what they're doing within their application so they can optimize CPU, GPU usage for maximization of performance. All these things bring complexities that make tools for developers, ecosystem tools, extremely important. A specification is not enough.
Excuse me. I think I really like the talks today about Vulkan being a general purpose environment. Speaking from a portability perspective, that extends to Vulkan sitting in the middle of a lot of things going on right now. It's possible right now, and I'll talk about this tomorrow a little bit more, to translate from pretty well any graphics API to any other graphics API using Vulkan as a middle conduit. So you can go from DX to Vulkan to, in my case, Metal. You can go from OpenGL through Angle to Vulkan to Metal, or to or back to OpenGL if you want, like, believe it or not. So there's a Vulkan implementation on top of OpenGL through Zinc. So it's just really interesting to see, not only from a platform perspective, Vulkan becoming, well, being the only industry standard, to Vulkan also being this conduit, API conduit, through which we have a lot of flexibility in terms of front-end APIs versus back-end APIs now.
Going last is rough. So yeah, portability, and like we use it for, obviously, to support multiple platforms at once. But what I really liked about the talk as well is the idea of trying to make it more general, go more low level, expose more of the hardware, and then create these open source modules on top, so that that are more specialized. Like you kept mentioning VMA and stuff like that. Or I think that there's good potential there to not have that necessarily in the API, but still offer a wide variety of things. And like people said, it was used for general purpose compute or graphics or anything.
Yeah, so I guess I want to reflect back on like Gabe's angle talk at the start of the conference. So Samsung already shipped a device where the only GPU driver is the Vulkan driver. And that means that even all the 2D skier stuff and whatever, it's all going through Vulkan anyway. It's like, it's a fundamental part of how we talk to the GPU on Android. And we have other IP blocks in a phone, importing data from camera, like neural network processors. We aren't there yet, but I can see a world in which like that also becomes at least importable and addressable from Vulkan. So I think Vulkan is, at least in the Android world, Vulkan is in a really great place to be the fundamental thing that underpins all communication with the GPU, and also allows you to get some access to other items as well, other bits of IP as well.
Well, I'm very happy that that it resonated with people. I want to add one little bit that was kind of missing from that is, so now like we see that there's some agreement. One of the things I'm thinking about, and I think the working group needs to think about, is how the spec is organized. And if you look at it, it looks like this list of functions and structures, and it's presented flat. But it's not really flat. It's like there's a memory model, and there's some memory management, and there's command buffers and synchronization, and it's layers. But we don't present it that way at all. But the driver implementers know that it's probably implemented that. Like that's how they're implementing it. That's how they're thinking about it. And the spec maybe should too, if it's going to evolve in this direction. Because when we really start talking about layering things, we want to be able to talk about it in terms of these strata.
Going into our coffee talk then?
Yeah. So that's why it's on my mind. So some of you are probably like, oh, he was just talking to me about that over coffee. So yes.
Because we were talking about this, and the spec, how I mean, it's everything at once and everything's there. So say I was working on what is it, inline uniform buffers or something, and then you sort of search for that, and your browser lights up, like there's like 1,000 results in there because it generated a lot of exceptions for a lot of functions. And so when you look for a particular bit, like you sort of hit it all the time before you actually get to the functions that are about using inline buffers. So it would be cool if things were sort of organized differently for when you only want the information, and then when you want correctness, or when you want, because it's just all there right now. And like your PDF anecdote and all that, like just, yeah, it's a lot to go through.
So there is a thing here that I think has been a long-standing challenge for Vulkan, which is the spec tries to serve two masters. It exists both to tell a driver and hardware vendor exactly what you have to implement in very precise detail. And then it kind of also tries to help a user understand it. And I think our current spec is a really nice detailed implementer's guide. It's really hard for us to produce a programmer's guide, which is kind of the thing that's missing there. And I will say, we have some work coming on documentation, but like it's definitely challenging to use the spec. And Chris's advice of like, yeah, keep a PDF. PDF search works a lot better than trying to get Chrome to load the whole spec. Whoever it was that asked, does everyone else take 20 seconds to load it in Chrome? Yes, yes, we do. And yes, we get annoyed when we click a link and it goes to the wrong version of the spec.
Speaking as an implementer, it's interesting. You know, we'll go and say, okay, we want to implement this extension, and the spec has very little about what an extension does, a specific extension, until you almost use just the extension as extension documentation in the spec as it's just a list of here are the new structures and here are the new calls, and then you got to go, oh, this extension is actually a pnext and this call way over here and things like that. And it's actually from an implementation perspective, but also from a user perspective, to understand what an extension is really doing and what the purpose of the extension was is actually almost like making up a puzzle from figuring out, you know, oh, well, this structure is supposed to do this, and this call is supposed to do this. I guess the whole thing is trying to do this. So, yeah, a higher level perspective would be very useful from like more of a top-down approach for both developers and implementers.
That's an interesting thing. So that exercise that you just described happens when writing the spec as well, and like when we'd be discussing it as a group, and you end up doing this connecting the dots thing. Or you're like, okay, I have this, and then I have this, and you're trying to keep it all in your in-brain cache while you put this puzzle together, and you have to reason through it. And it's like, yes, all the dots are connected. It doesn't. It has to be that way because it's a technical document. But the problem is exactly this: like, how do we? If implementers are struggling with this, and you have to do that. Like how many Vulkan implementations are there? There's like 10 or something, but there's hundreds of applications, and they all have to do that as well. And surely that can be improved.
From the extension perspective, the introduction of a formal proposal document has actually captured a little bit of that. So the last, however long it's been, but the last, generation of extensions, it's actually been easier because of that proposal document, because somebody has to actually now write down, here's what we're trying to do with this, and here's how it's sort of all pulled together, so that there are movements in the right direction there.
Great. Do we want to? Does anybody else have any thoughts on this topic, or do we want to source a new topic? And we have a new one.
Matt Kalan, Devs Graphics Programming. So my question is mostly about what do you think about the state of all the different compilers for generating Spivi with regards to GLSL, HLSL? If there is some will to take some, I wouldn't say, well, take some responsibility, that's kind of like a charged term, but essentially to contribute to the LLVM Spivi out story, and also if any of the panel members are aware of the Circle C++ shaders project by Sean Baxter.
Anybody?
Yeah, so I guess there's a lot to unpack there. Let's start with the Circle C++ one, because that's easy. Sean has engaged with the Spivi group. We have talked to him. So yeah, we're aware on that one. In terms of high-level shading languages, I would say GLSL is probably in the state it's in. We will continue to make sure that extensions work with GLSL. You're probably unlikely to see like a major modernization of the language for GLSL. You're unlikely to see templates and all that kind of generics and stuff end up in GLSL. HLSL is in a better place as a modern shading language. And when we've talked to developers, the feedback we got was that HLSL is largely where they are. And so we think in terms of direction, probably most of the effort will go there. For the LLVM thing, I think we're keen to engage. There's probably a matter of letting it land and settle in. Like Microsoft stuff needs to land and settle in LLVM before we can engage too much. For the time being, there is maintenance stuff on DXC, which I guess Karen is probably able to speak to a bit. Or at least Karen's looking at me and I'm pretty sure she'll have something to say on this topic.
I have multiple random thoughts in my head and not sure how to sort these out. The first one is every year we do these ecosystem surveys and we ask what people use for their workflow. And every time we do this, it's actually the GeoSlang workflow coming from GLSL to Spivi is the highest hitter on workflows that people use. And then HLSL is following. So I find that interesting because there is a lot of emphasis or importance put on HLSL, and I'm not trying to say it's not important. I suspect that is perhaps because a lot of the AAA game companies have DirectX related applications, all their shaders are in HLSL, so that's why it's so popular. I do believe, or I know for a fact, that the tools for HLSL to Spivi are maintained at a slow rate. I think maybe is a nice way for me to say it. I know that people put up PRs and it could take a year before they actually get approved or merged. I know that in terms of inside Lunar G, the actual headcount we have to work on shader compiler is very limited. Validation layers just have us running fast and doing SDKs. And so we don't have a lot of resource to contribute. You heard from Greg earlier today, who did a lot of the shader debug information. We're starting to try to get some more resource to look into the DXC to help with some of the maintenance issues there. So those are kind of my random thoughts.
I think still GLSL is important. And one of the reasons is that we still have a lot of OpenGL applications out there. It's not just gaming when we try to convert to Vulkan. So in order for us to make the transition easier to Vulkan, we have to still be able to support these new features in the language. It's what I think.
Yeah, and that it puts us in a tough spot because it's tempting to not invest any further and just be in purely maintenance mode. But that's a very good point. And then one very big application that's using GLSL that we know is the CTS. And so you introduce new things in Vulkan, and we have the CTS using GLSL. We're sometimes forced to add stuff to it, or at least the output, the compiler output. Has anybody looked at Wigsel, the web GPU shading language? Oh, a few people have. Not meaning to be provocative again. Do you have a comment on it?
Andrew Mengade. I quite enjoy WGSL, and I find it pretty semantically like it makes sense. And I actually recommend WebGPU to anyone coming in from OpenGL who wants to learn the concepts without the icky implementation stuff.
Interesting. Yeah. I haven't looked at that language. I have no idea how primitive it is or how advanced it is, only that it's a newly arrived shading language.
I'm going to show my ignorance here, but is there a converter from the WebGL language to Spivi?
I think yes, because there is Naga by Mozilla, I think, part of WGPU. And maybe possibly one more project that I can't remember the name of.
In Dawn, perhaps. So Dawn is the web GPU implementation that has a Vulkan backend, so it must emit Spivi at some point.
Yeah, it's an interesting. It'd be interesting because I guess what I'm hearing here is there's a fundamental non-canonical high-level language that would feed into Spivi. Right now, everybody's kind of taking something existing and merging it in, or in the case of the C++ initiative, sounds good, sounds interesting at least. And I wonder if Khronos should be leaning towards defining a high-level language that is separate from GLSL, that would allow us to grow it in the future in the same direction that Spivi is going to grow, so that when we hit things like your concern, Chris, about CTS and there's new Vulkan features that we can't actually write shaders for in a high-level language right now. So we end up creating Spivi assembly shaders instead, and that's painful for everybody. So it would be interesting to have in the future a language that is meant to drive Vulkan, specifically that is a high-level compiled language.
So my contentious answer to should Khronos define a new high-level language is absolutely no. Like, it's a massive amount of work. When I said that GLSL is unlikely to get features like generics, like that's also because it's a massive amount of work. Like, I think GLSL is strategically important to Android. Like, we have to keep it in a functional state, but the amount of engineering effort that we would put into a new language, and then the amount of effort that we would have to put into going out to developers and evangelizing and trying to persuade them that they should throw away their massive reams of HLSL content and switch to our new language, I don't think that's a sensible use of our time and resources.
Sorry, I agree that creating it would be a massive undertaking, but I would disagree that we would need to tell people you have to scrap your existing GLSL or HLSL. The idea would be in that scenario would be to transition over. So if you're writing a new shader, use the new stuff. If you've got an existing thing that's working fine in HLSL and it's porting to Spivi just fine, then stick with it.
I think nobody wants to write a new shader in a new language if they can only use it with Vulkan. I think if they can't use it with other APIs, they are not going to be interested.
You'll never be able to deprecate the existing one, so you'd be adding to yet another language.
Is this on? Okay. Hugo de Villas from Saarland University. I'm actually a giant believer in single source frameworks and languages. We have seen a lot of this in the compute world, where it's sort of an untold standard or expectation. So my perspective on this whole problem should be that whatever the shading language ecosystem should be is matching whatever the host language is, which is Khronos doesn't particularly burden itself with supporting every binding for every language either. And likewise, I don't think they should bother with creating a shading language that pleases everyone. I think ultimately the best shading language is the same language that everything else is written in, and so the effort should be spent on making it, making Spivi and Vulkan overall a pleasant compilation target. So whatever new language people make up, and people sure love to make new languages, they can adapt. Like, we can also use it on the GPU, and so you don't. The idea would be to spend resources on making the life of new shader language developers easier, and sort of get the responsibility of supporting new features away from Khronos.
What's wrong with Spivi currently in that area?
Well, if you ask people from Rush GPU and whatnot, there's a lot of if you look at the Spivi spec, it's clearly derived from the semantics of GLSL. So you have things like logical pointers or structured control flow. These are the two typical big hitters. These are things that you can either accept as intrinsic limitations, and you end up with a language that is in flavor very close to GLSL or HLSL, or you can try and get away from it, and then you have the problem of having to engineer something very complicated with some kind of emulation, or relying on new extensions like buffer device address and having to cut off anything that doesn't meet that bar.
It's not directly to, I'm sorry. It's just I didn't get a chance before, but like from my perspective is like, so we use HLSL. So I mean, I think the problem right now, is that the effort is divided between GLSL and HLSL, and they both have very compelling reasons to exist. And so we're doing HLSL, and so we're like, the effort going into GLSL could be going towards more HLSL features, and then I'm sure the opposite's also true. And as for the progress, like I was working Project Stream way back in the day with Chris, and the compiling HLSL, we were working with like AAA game and trying to compile the shaders on that was challenging. And the amount of work that's put in, like, we've come a long way, I guess is what I'm trying to say. Like there's still some effort to be put. Like we have a dedicated resource right now. If I have shader compilation issues, we have a dedicated resource for that, because it's that important and it happens that often. But yeah, I think it's kind of weird that there's this disconnect where we have Vulkan that's managed by the working group, and then Spivi, but then in the middle, the thing that brings your Vulkan program and that brings your shader to the is not owned like directly. I know. In the case of HLSL.
I think because that's actually an interesting story, and I'll give you the very short version of it, which was it was when we were launching Stadia, we had Vulkan and no way to get HLSL into Spivi, and we were trying to ship these AAA games that really did not want to rewrite all their shaders. So in the end, we ended up getting the Spivi backend into DXC. And I think what I'm kind of reading with people, their sentiment is exactly what Jean-Noé said, is it makes people a bit nervous that we have the spec and Spivi and this thing in the middle that's really not controlled by this group at all. And that makes people nervous. But I would say the evidence is that that's not really a big concern. Like, we were able to do it. We were able to do it in collaboration with the entity controlling DXC, and get it done. And we made it work. And so I think I understand the sentiment. I think in practical terms we're okay, and I think all the sources out there at this point.
I just wanted to speak to the comment about making Spivi a friendlier compilation target, and maybe roll back the clock like 6 years ago or something and say, I really wish we hadn't ended up with like a Spivi, like an OpenCL variant and a Vulkan variant, but there was a product that had to ship on a timeline, and we wouldn't have shipped Vulkan if we had solved that problem at the time. And as a result, we inherited many years of technical debt. And I think that's an area where you can expect us to be trying to squash down the gap. Like, it will take time, but I would like to see a world in the future where there either aren't two versions of Spivi, or there's two versions of Spivi that are a lot more compatible with each other than there are today. Like, nobody's happy with that situation, but there were technical reasons why it happened that way.
Thanks. Perhaps I should have led by saying that I am indeed very grateful that Spivi exists. It's far better of a compilation target than GLSL or, God forbid, OpenGL assembly language. So yeah, I agree with your assessment. I think things are going in the right direction. I'm just encouraging them to pursue.
I guess you said something about, thank God that Khronos is not developing another language and that it's a lot of work. Obviously, I do agree that it's a stupid amount of work to make a new language, but what about a subset of an existing language that's popular?
I mean, if I'm slightly cynical, Spivi has maybe allowed hardware companies who are good at producing hardware to get out of the high-level language business, and I kind of rather let the compiler experts do the language stuff. And like, Spivi serves our needs, and like, Khronos struggles to do language stuff. And in the GL days, we were forced to do language stuff because we needed to get content in. Like, I think the argument about making Spivi a good target for languages is a better way to do it than Khronos spending time trying to design languages themselves.
So yeah, like, already we're dividing our effort between GLSL and HLSL. I mean, if there's a third player there, then we're dividing our effort further. I don't know. It's just, and if, so from my perspective, again, if I just keep going with HLSL and then I see another one appear, like, oh man, another person that's going to be taking, because the amount of effort, like, it's finite, right? We have these resources working on this, and then the more we divide them, the more, the less work you see in the one you happen to be using.
Worried about split vote like every election in Canada.
I'm Canadian.
As am I.
I'll also just, that comment about finite resources, like, as a former compiler engineer, GPU compiler engineers are like gold dust. Like, we don't have a lot of that resource to spread around.
People are passionate about their programming languages. That's another universal truth, along with the death and taxes stuff. Should we change topics again? Krista. Let's get it on the mic so it's recorded.
Maybe to extend the discussion we just had, what for maybe everyone in the panel are the where the effort should be put in the Vulkan ecosystem or the Vulkan specification. But when I'm saying Vulkan ecosystem, I want to include everything. So where do you see there is the focus should be put on in development for the benefits of the ecosystem, but more developer ecosystem people?
Yeah, no, it makes total sense to me. I think let's see what the group here thinks. I've thought about this a lot, and I'm trying to figure that out. And I would actually like everyone's opinion as well.
Yeah, that's a hard question. So maybe I'm very colored by Chris's presentation earlier. Like, I think there's a lot that we could do to address complexity and like ease of onboarding, and like I think Vulkan is becoming less, in a way, the more we add on, the less accessible the API becomes. And I think we could do a lot in terms of making it easier for developers to get going and get started.
Now I wish I were last. So, but again, following Chris's presentation, as I just find right now that we're in a state where there's just more and more stuff getting added, and finding ways to manage that. So for the Unreal Engine, so we use Vulkan on Android and Linux, say, they have very different velocities for the drivers and all that. And on Android, we need to support devices that were out a long time ago that aren't getting driver updates anymore. And so we always have, so we see this shiny, cool new feature, and then we want to use it, but every time we're diverging. We have branching code paths that need to run because old devices don't have the feature, new devices have the feature. I think we should put some effort into managing that. We said it about the documentation, but it goes for the rest. I really like what was done for synchronization too, where if you don't have synchronization too, we have a layer that will emulate it for you. So you could assume that synchronization 2 will always exist. If they don't have it, then you have this other layer that could just translate it into regular commands. Like, so if we did that, if for certain features, like we were talking about another one, this was part of our coffee talk, that's why I'm so chatty. It was timeline semaphores. Timeline semaphores is something that could totally be emulated. So we could be like, Vulkan 1.7, you need to support timeline semaphores, period. And the people who can't, that could be emulated with a layer. It could be part of software. And instead of every driver having their own software for that, we could just, again, have this common component that could be shared by everyone who doesn't have it in their driver. And then that would allow us to sort of not have to carry all these old devices with all drivers all the time. We could just emulate some parts of it with software as we go forward. I give you enough time to think about something there.
Karen, you looked like you had something to say.
Well, I think there are multiple things in the ecosystem that could be done. I agree with Ralph about tools to make it really much easier for developers to get started. I'm concerned about all the extensions and the complexity that is being added by that, and can only imagine it must be difficult to know for applications to know how to sort through all those extensions and what do I need to support and not. And I believe that the profiles, which have just come out with 1.3, are in their infancy, and the tool set around that, and I'm hoping or believe that there's getting more people in the ecosystem familiar and using those could be very helpful. The thing I hear consistently from any open-ended comments when I ask what are people's pain points while developing, synchronization, cross-platform profiling. Those are two really big top hitters. Synchronization is just hard. And I can tell you that writing validation code to catch synchronization errors is really hard. And that's why it's taken so long for us to get out what we do have in the validation layers, but there's still more to do. And I think even when people get validation errors on synchronization, they go cross-eyed and don't know what to do with that error. And so there's room for more tools, be it offline or whatnot, to help developers interpret those synchronization errors to find out what they really did incorrectly in their application. Those are the things that I remember top of mind that keep coming up.
So I'd like to add that I agree with Jean-Noé here, but I'd like to add that compatibility with other APIs is also very important. So one of the things that we do is we make games that were written for other APIs work on Vulkan. So that means that we also need to follow what happens in other APIs and enable that functionality in Vulkan. So I think that's going to be still important to us in the future. But also to reply to what you said, I think we have some conflicting goals here. So because we want a low-level API, if you expose so many low-level details, of course, it's going to be complicated, right? And I don't think there is a way to avoid that completely.
I guess I'm not saying avoid the complication. I'm talking more about tools that people navigate the complication is really what I'm referring to.
Yeah, that sounds reasonable.
I agree about tools. We need more tools. I agree that Vulkan is complicated because we need to have the flexibility to control the hardware. Because when you have people who are architecting systems, you want to have the flexibility not to go to IHVs and ask for small features that you could actually implement yourself. But you definitely have to have like a starting point to have something to work, like let's say a set of libraries that you could use for different purposes. We have already like sample code from Sasha. We have the Vulkan SDKs, which actually help with this, but maybe you could do more work to come up with those different libraries that people could start with, and they do very simple things instead of thinking about all the details of the APIs. And then if you really need to do something a little bit different, then you have to dig into the APIs and see how to do it, or do documentation and do it. What I think should actually happen. We're developing new features, new APIs, and complexity is definitely there. More, for example, we could tutorials like what we have here definitely helps with a lot of this. Maybe more guides need to be provided to help with how to use the APIs. Like synchronization is not that difficult. Maybe just if it's structured in the right way, then maybe it would help developers make the right decisions. So.
It's great. What I found most interesting about all of this is everybody has a different idea, and I'm sure as we moved across the stage, some people were like, "Oh, my idea was taken," but these are all still important things. Everything from API complexity to having to handle new extensions. Somebody said something earlier. I can't remember if it was at lunch or when in the questions that we're adding extensions faster than they can be consumed on the application side. That is a wild statistic that that's the first time I've heard it and hadn't thought it. Like I knew we were generating a lot of spec very fast, but that's frightening actually. So that's something that needs to be thought about for sure. But very much, this is how I've been thinking about things is I'm trying to figure out how this puzzle goes together a bit. Like what is there's a lot of problems that we have to solve and don't know how yet. Yeah.
A couple of things, yeah. One was what you were just talking about extensions coming out very fast, and in a lot of cases, extensions are driven, seem to be driven, I should say, by specific need that one user may have that then adds a whole bunch of complication, not necessarily complications, but is really not going to be consumed by a lot of other users. Because they want, the goal for that first user may have been, I just need to eke out a few more frames per second or something like that. Another trend that has popped up in the last year or so is the move to more dynamic stuff. So when Vulkan 1.0 came out, we had a very strong goal of saying, you know what, we're going to lock down pipelines, we're going to lock down the things that cost within a driver, within a GPU, and we're going to make the amount of dynamic stuff you can do very, very small. That list of dynamic stuff has now grown significantly, not just in terms of whether you can do viewports, but also now dynamic rendering. So I don't even need a render pass anymore. Dynamic pipeline state, and I don't mean just the small stuff. I mean I can now create pipelines on the fly from other little pipelines and stuff like that. So it almost feels to me like the hairs on the back of my neck are going up. Are we heading back down to the old ugly OpenGL days where everything was dynamic and it was up to the drivers to figure it out? And then you get the problem there is you get glaring inconsistencies in performance between driver to driver, because some drivers can optimize better, some specific thing better, some specific dynamic state better than other drivers. And I wonder, we seem to be heading in a lot of different directions, is what I'm getting at.
That resonates with me quite a lot, and Ralph's probably going to smile at me just now. Yes. This terrifies me as well. And actually, while we're here, before we get to Ralph, just I'm curious, because when we talk to developers, a lot of developers, they want more dynamic state. They want last minute decision making. They want to be able to just if then else, set, draw. And who here wants more dynamic state? Be brave. And yeah, or would you rather have it all in the pipeline and then you don't have to worry about it? You just set the pipeline. Yeah, it's about the same. Interesting. Yeah, very interesting. Ralph.
Yeah, so I think I commented to Chris around lunchtime that like Vulkan 1.0, we had quite a opinionated vision of like how certain things would work, and pipelines was one of them. Like, it's absolutely true that if you give us as much state as you can, as early as possible, like if a compiler knows everything, we can bake in everything, we can do the best that we possibly could. And we had this view back in the 1.0 days that like the engines would change, like the engines would adapt to fit what we wanted to happen. And to be fair, that was also the feedback we got from the developers back then. And I think we all had a brave vision about where we were going. And I think the reality is that people have made massive investments in engines that were designed a certain way. Like Chris made a comment earlier about like he was working on his type project and like frame buffers get in the way everywhere. Like when we spec'd the API, we didn't realize what pain that was going to be. But when somebody actually tries to use it, then we discover that yes, it is. And people come and complain that like, yes, this is really awkward to work with. And we have to work back to accommodate that. Like, I'm kind of nervous about adding more and more dynamic state. Like I wish the static pipeline model was panning out, but like the amount of feedback that we get that more dynamism is wanted it's very hard to ignore.
It gets conflated with the pipeline compilation problem as well, right? So it's like, just add more dynamic state so I don't have to compile so many pipelines, right? Because that takes time and I don't want to spend that time. But it's not just that, and it gets conflated. And that's one of the difficulties with talking to developers about what they want, because the reasons can be different.
It's not just time, it's also disk space. So
that's true.
We
John,
ship
there's a
these
fun story
shader
about that.
caches on the Steam Deck, and those can be huge. Like for some games, several gigabytes of just shader caches. It's insane. So looking at it from that perspective, I think these dynamic things can really help here. And I think it's fine as long as we allow developers to kind of fall back to the fully baked thing for where it really matters for the performance.
Hot take.
or maybe just have some kind of hint, some kind of performance about some kind of information about what the platform prefers. Like this state has a high cost, this state does not,
Yep.
and then our code can adjust because we'll have to. In my case, I'll have to do both anyways. So
that was some feedback we got whilst we're on this topic. We did we surveyed the VAP, which is the Vulkan Advisory Panel, for information on this when we were starting to talk about the pipeline management issue, and that was one of the things that was brought up, was some sort of introspection API so that they can understand what this does. Like, is this just poking a register, or is this affecting my entire compilation of my pipeline? We haven't done that, and it sounds scary to expose that. But going back to like what I was talking about this morning, that's the kind of compromise we end up making in the API. We're like, we don't know how to solve this, so we're just going to surface this and make the developer deal with it. That might actually be the solution. Maybe that's something we could do, but it still sounds awfully terrifying. I think I saw Christoph's hand go up.
Personally, I always think we should not solve problem with API when there is other solutions. And we have another solution. This is the best practice mode of the validation layer. And so if a dynamic state is slow on your driver, just make a PR on the validation layer. And when the developer use that flag, just output a warning to say, hey, you can do that if you want, but you are going to pay a cost for that. And that will be much easier, no spec development. This said, not every vendor, and I'm not sure how much time they spend to update the best practices, but at least not every vendor has best practices in the validation layer. So personally, I would highly recommend the vendor to invest if they really want the games to be fast on Vulkan, to invest in the best practice layer that is very easy to use for any developer. Just run your application on the validation layer. That's 2 seconds with Vulkan configurator to do.
I would like to respond to that. When I was asked or answering earlier about where are areas in the ecosystem that we should develop, I was trying to go through my memory of things that are said by the developers in the surveys we do. Best practices is another one that comes up constantly. But they quite often ask for it in terms of, I would like a document that tells me best practices for various implementations. But there is a better way to do this. And that is if implementers would add the best practices appropriate for their hardware into the best practices of the validation layers. And to date, I think we have 3 hardware. I know AMD did it. NVIDIA did it. ARM did it. Who's the 4th? In Imagination. But yeah, that's the way to get so again, you're using the API just fine, you're conformant, but being able to give hints to the developers of this may not be the best thing you want to do on this implementation.
I was just going to say, I wonder if we need to have the ability of the API to perform more or return more suboptimal codes, not just for the on the WSI side, but also, like if you pull this pipeline together like in this way, this is going to be a suboptimal response.
That's not a bad idea. I'm gonna before you get to John Noe, because you could do something then. You could be like, oh, and then spin off a background thread or something to build something more optimal. If it's something that's expensive for you or something like that, maybe.
I really like the idea of the layer and all that, and I'm all for it. But I think there are some cases where it might change from one generation of hardware to the next, or the software is already shipped, like some Unreal 4 game, and if it branched on if this is good for you and if this is bad for you, then the API would need to return that information because the developer's not going to go patch the game for a new GPU like 5 years down the line and stuff like that. So I think a mix of both would be useful in my opinion.
Yeah, I was just going to comment on the docs versus layers one. Is the problem with layers is you've already made the mistake by the time you actually find out. So when you're looking at new things coming up, you still need the guide to kind of explain how to go and build the engine, how to go and integrate the new feature. layers are great, right? Absolutely need them, but it's not enough by itself.
So I like Christoph's observation about the best practices layer. I actually wanted to ask the audience a question. So best practices is something that you have to opt in to enabling. I'm kind of curious how many people have ever actually tried it. Okay, that's better than I was expecting.
Yeah, I'd never run the configurator tool. I had run it, but I don't use it in my daily. I always do everything through code. And I think I'll stop doing that. We do need to solve the Android problem, so I need to figure that out.
Yeah, all I said earlier is it's really easy to enable best practices through vkconfig. Any of the validation layer options are exposed through vkconfig, so you don't have to figure out the complicated way to do it with environment variables or code.
No, we'll get it on the mic so it's recorded. Who's got the microphone? Tim's coming by with it.
So I kind of wanted to state that up till this point, we've only had IHV feedback for best practices, but as engine developers, I'm going to call you all out. You learn things that, hey, this really works well. Why aren't you feeding that back into best practices? I mean, you guys are learning these experiences, and I would even say the audience here. I mean, the people who did the fast FFT work, you know, you've learned things. Feed some of that back into the community because other people will benefit from your experiences and your pain points. Is there a reason, like the developers on the stage, why you haven't fed that stuff back?
You're up, Jean-Noé. You can just say, I'm not allowed to talk about that.
I think that goes that goes across the board. That sentiment goes across the board. It's important for everybody in the ecosystem to understand that that Vulkan is effectively a voluntary environment. It's completely dependent on contributions from everywhere, whether it's the working group, you know, defining the spec, but also users who are providing input to that spec. In my world, code contributions. You know, a lot of this is open source, so code contributions through PRs are very helpful. So it's not just, you know, a panel like this kind of telling everybody how to do things. It's a whole ecosystem where you know, users can contribute just as much useful information into it as the working group.
And actually, to add to that, you can get involved. There are pathways to this. Marty had some great links on that yesterday, and I was going to actually harvest them and throw them into my talk, but I didn't. I was doing the slides until like minutes before I was talking about it. But so there are ways. So if you're interested, talk to Marty. Talk to your employer possibly to see if you can get some time dedicated to it. It's an ecosystem that we all benefit from. That hopefully we can use this to build the technology that all of our core businesses are built on, instead of building that core technology in isolation.
Hi, hello, Andrew again. Just to agitate, I will state that WebGPU has documentation available on best practices.
I'm at a loss. I know. I mean, we kid, but I actually, I think WebGPU actually looks like a very good piece of spec.
I was just going to say, we keep all our advice, we bottle it up, and then we go to conferences and we give talks about it. But maybe directly to the best practices would be a good idea.
So we're supposed to end 4 minutes ago. I don't want to keep everybody here on the stage. It's a bit of a hot seat. Any last minute need to know pressing questions that you could get out of any of these 7 individuals right now? Okay, one more, Dimitri.
That's also an old question, and I'm Dmitry from ETH Zurich, and it's mostly to NVIDIA. Can we have more than 48 kilobytes of shared memory, please? Yeah, it's usually done with dynamic allocation. I don't think Vulkan allows that.
So I was very curious about your talk, and you said something about NVIDIA lacking some features. I'm very much interested in hearing exactly what you need, and I'll make sure that you have it next time. So you don't have to bring it over and over again.
That's great. Awesome. Thank you, everybody, for the lively participation. Thank you to all the panelists. It's been wonderful. I hope you're all really enjoying the conference so far. I know I am. And we'll see you all tomorrow.
And